Okay, so let's start today's lesson. Okay, everyone's here. Okay, so first, before we continue, this is the word file. The word file, you have to fill up something about this file. Okay, let's recall back what we learned yesterday. First thing, you need to fill up here what is meant by electric field. Okay, what is meant by electric field? So, what is electric field? A region where a charged particle experience force. A region where charged particle experience force. Okay, then don't get confused with electric field and electric field strength. Then, what is electric field strength? So, electric field strength is defined as electric force per unit positive charge. Force per unit positive charge acting by the field at that point. What is the equation you learned yesterday? The two equation you learn is what? What's the equation? So E equals to what? E equals to F over Q or V over D. The unit is what? Newton per coulomb, or could be volt per meter. So you write the units in this formula. Okay. So then we talk about the movement of the charged particle, parabolic path. So projectile movement they can ask. Yeah, so that's what we've done. Okay, so today we're going to talk about another part. We're going to talk about electric potential and potential energy. Okay, electric potential. Okay, so you see this diagram. The field is to the left. So the plate is vertical or horizontal? The parallel plate. It's vertical or horizontal? The parallel plate should be vertical, right? The parallel plate is vertical. And the parallel plate is vertical. You have to imagine the parallel plate is vertical. Which side is positive? To the right should be positive plate. To the left is a negative plate because the field is directed to the left. Okay, so this is a uniform field. Okay, now let's see. We have a charge here. We have a charge, positive charge here. Okay. Of course, the force due to the field is to the left, okay, because positive charge attracted to the negative plate, and the force we know is QE. Okay, let's say this charge is we apply a force. We use our force. Okay, apply a force, moving the charge from left to the right for a distance of t. The charge is moving from left to right for a distance of t. So what happened? There will be work done by the field. There will be work done on the charge. Okay, work is done on the charge. Okay, so if the charge moves from left to right, tell me, it gain potential energy or kinetic energy? Left to right, you gain potential energy or kinetic energy? Anyone? The charge was let's say it's fired. It's fired. Fired means fired, so that it moved to the right and it slows down. So it gained potential energy or kinetic energy? Anyone? Anybody?
Potential.
So it gained potential energy. So why it's the potential energy? Because positive charge moving close to the positive plate. Positive charge moving to the positive plate, it should slows down. So it gained potential energy. So it gained potential energy, and it should lose what? Should lose kinetic energy. Kinetic energy must lost kinetic energy. Okay, so but anyway, the work done to bring the charge from left to right, what is work formula? Work is force times distance, right? The force you apply times the distance. the force you need to apply must be at least equal to the force by the field to the left. So it's QE, and you track a distance of t to the direction of the force. So the work done on the charge is QE. Okay, the work done on the charge is QE. This work has been converted to what? Gain in what? Gain in potential energy. Gain in potential. Potential energy has been gained. Okay. Yeah. So if the charge is moving from right to left, let's say it moved from right to left, then what happened? The work done still going to be QE, still going to be Q times V. What is Q? Q is the charge possessed by the particle. What is V? V, we said the potential difference. The V is what? The V is the potential difference. The V is the potential difference between the beginning to the end point. It's called potential difference. Okay. Let's say from here to here, from the plate to plate, maybe apply here 0 joule, 0 volt. Maybe here is 50 volt. Okay. 0 volt, 50 volt, separated maybe a distance of, let's say, I make it easier. Let's say 5 centimeter of separation. Okay, 5 centimeter of separation. But let's say the charge only move for a distance of, let's say, is only 2 centimeter. Only 2 centimeter. So what is the potential difference need to be used here? The V. Anyone? 0 to 50 volt, 5 centimeter separated. So for 2 centimeter movement, how much the voltage should be? The voltage differences between the distance. So it's basically ratio. So 5 cm has a potential difference of 50 volt. So the 2 centimeter must have a potential difference of how much? Ratio 2 divided by 5 times 50. Okay, that's the potential difference. So it should be what? Should be 100 divided by 5. So it's like 20. Should be 20 volt. So 20 volt is the one need to be used here. 20 volt. 20 volt. So the work done is Q times V. The V must be the potential difference between the beginning point and the end point of traveling. It's only a 2 centimeter part, let's say. That means the potential only should be used here as 20 volt. So work done is Q times V, 20 volt. Okay, so that's the potential difference. You don't need to use the entire potential difference. You only need to use the potential difference between between the points, the beginning point to the end point. Okay, so when the charge is moving, work has been done by the work is done. The work done is QV, Q times the potential difference. The work done will convert it to some sort of energy, depend to which direction it moves. If the positive move closer to the positive plate, then we say the work done is converted to a gain in potential energy. Okay. If the charge is moved from, if a positive charge moves towards the negative plate, and we say the work done is still QE, but now it should be gain in kinetic energy. Should be gain in kinetic energy. Yeah. So you have to check which side is moving on. Positive get close to the positive plate, it should slow down. So you must gain potential energy. Potential to do work. Okay, any question from this slide? Okay, just introduction. Okay, so in this topic, graph involves. So when a charge moves from one point to another, okay, the electric field strength versus the plate separation. The plate separation. Sorry, the x. The x. This is your plate separation. X is you are moving a distance of. Say I put a d, but d better. D distance you are moving from left to right. The electric field going to be constant because it's a uniform field. It's a uniform field. E versus D should be a constant. The particle should experience a constant force, of course, because if E constant, force must be constant because F is equals to what? QE. As long as E constant, F going to be constant. Okay. Next, the potential. Something new. The potential. The potential when you move from, let's say, from this plate, from 0, from here, you move towards the left plate, 0 to D, the voltage will rise from 0 volt. Let's say this plate is vertical, right? This plate is vertical, vertical. Let's say this is positive 50 volt, and let's say this is 0 volt. So the voltage must start from 0 volt and must reach how much? Must reach 50 volt and reaching the negative plate. So the voltage will rises with the same rate. Okay, so V versus T, the graph going to be a straight line with gradient. And can you tell me what this gradient represents? Anyone? V versus T, the gradient represents what? Anyone? Electric field strength. Very good. The gradient is electric field strength because you know what electric field strength is V over D. So the gradient of the V versus D graph is the electric field strength. It's electric field strength. Okay. So remember, if you have a parallel plate, when you go from the 0 volt to the 50 volt, let's say every centimeter you rises, the potential going to increase linearly. Will increase linearly. Okay. So the electric potential difference, electric field times the distance. So it's volt actually. Potential increases as a moving against electric field. Work done to a unit charge. Okay. Now your turn. Look at the diagram above. Okay, like diagram above. How much of work has been done on the charge? Okay, to move the charge from let me okay move to move the charge. This is the first location. Okay, this is the first location. This is the second location. What is work done to move the charge from 1 to 2? 1 to 2. The angle of vertical from vertical, this angle is alpha. Is alpha. Okay, and the distance it was traveled diagonally was d. Okay, and the force is of course acting down as a positive charge. What is the work done by you to move the charge from 1 to 2? Give your answer in terms of d, alpha, and q. And of course, you can use electric field also if you want. Okay, d, alpha, q, and e. How much is work has been done on the charge? Okay, so try to get the formula based on work derivation. What is work? Work is force times distance traveled to the direction of the force. Use this, get the final answer. What is work done to move diagonally in terms of D, alpha, Q, and E? Because it moved diagonally. So anyone, because it's alpha somehow, force is downwards, so you need to apply the same force upwards. The same force need to be applied upwards so that it move up. Anyone? So maybe we can do together. Okay, so this is the work, right? So the work is what? Work is, as I told, work is force times distance traveled to the direction of the force. The force we know is QE, Q times E. Okay, the force you need to apply it upwards. You need to apply the force upwards. The distance you're supposed to use, if you really understand the work, is the distance traveled to the direction of the force. So the distance you're supposed to use, the force you applied is upwards. So the distance you must use is the vertical distance. The vertical distance. You have to use the vertical distance. So the D you have to resolve vertically. So you should get D cos alpha. Okay. So the work done is QE D cos alpha. Okay. But we know ED cos alpha is the potential difference. Yeah, so electric potential. As QED cos alpha is the work done. You can leave it here. So when the particle move from 1 to 2, tell me, this is the work done. This is equals to gain in kinetic or gain in potential. The particle gain potential or gain kinetic? Anyone?
Potential.
So it gain potential. So it gain potential. So it's gain potential. Okay, good. How do you know? Because it's a positive charge and the upper plate is, of course, is positively charged because the field is downwards. So this is, so then it goes upward. So the positive charge get closer to the positive plate. So gain potential. Okay. How much of gain potential? Same as the work done by the force. QED cos alpha. Okay.
Sir, isn't
Yeah.
going towards the positive, it wants to go to the positive, like it gains kinetic energy?
Again, if it goes to the positive plate,
Yeah.
it will gain potential.
But
Because,
isn't it kinetic because it moves towards the positive plate?
no, the kinetic should lost.
This is an electron, right?
Yeah. You see, if let's say you throw, let's say for example, the upper plate is positive, down plate is negative. Okay. Let's say a charge is fired with a certain velocity. Okay, certain velocity fired. That means the positive Q as at the beginning as a kinetic energy, at certain kinetic energy, it was fired. So when it go to get close to the positive plate, what happened to its kinetic energy? Drop or rise? Because positive charge get close to the positive plate. The positive charge and positive plate are going to repel, right?
But electron is a negative charge.
Yeah. If electron is a different story. This case is a positive charge.
Or positive charge. Yeah.
Yeah. So positive charge get close to the positive plate. If we fire, let's say we fired, then the kinetic energy should drop. The potential energy should rise. Yeah. So that's why potential energy gain when positive charge get close to positive plate. If it's an electron, of course, if you fire it, yeah, when it get close to the positive plate, the electron will gain kinetic. Kinetic will rise, but potential will drop. The other way around. Okay. Okay. Now you need to understand a term called equipotential line. Something called equipotential line. So you see the first field here. The parallel plate is vertical or horizontal? Because the field line is downwards. So the parallel plate should be horizontal, right? It's horizontal, up and down. Okay. And upper plate is positive. You always need to visualize the parallel plate. So yeah, the field is going downwards. But let's say this is a positive 10 volt, positive 10 volt and 0 volt. And this is separated by, let's say, to make it easier, I put 10 centimeter. Okay. So every 1 centimeter going down, what is the potential here will be? Positive 10 become, anyone? This is the test separate by 10 centimeter. 10 volt, 0 volt. If you go down by 1 centimeter, what is the potential here will be? Positive 9 volt, right? If you go another 1 centimeter down, the potential here will be positive 8 volt. So finally, the voltage is going to drop to 0 volt. Okay. So you see here, the red line. Our focus here is the red line. The red line is a line joining all the point which has the same potential. All potential here is the same, which is how much? Positive 9 volt. That red line called equipotential. Call it equipotential line. Okay. Equipotential line means a line where the potential is the same. Potential is the same. It's called equipotential line. This line got something special. What's special? If let's say a charge is forced to move to the direction of the equipotential line. If, let's say the charge is moving along the equipotential line. What is the work done on the charge? If you move along the equipotential line, what is work done on the charge? What is work? Work just now, the new formula is FD but later we found end up Q changes in voltage and changes in voltage. So in this case, if the charge move along the equipotential line, work done will be what?
Is it 0?
0. Yes, the work done will be 0. No work has been done. If a charge move along a equipotential line, there is no work done on the charge because it moved with the equipotential line. No changes in V. So if the charge move in a equipotential line, no work is done. Therefore, the charge, do it gain kinetic energy or potential energy? You don't gain anything. No work has been done means changes in EP. The gain in EP is 0, no gain. And gain in kinetic also will be 0. No gain in potential, no gain in kinetic. Okay, so work done. So that's a specialty about equipotential line. Any charge along an equipotential line, no work is done because no change in potential, therefore no gain in potential, no gain in kinetic. Okay. Any questions from here? Okay, so let's continue. Okay, now in exam they might ask you to draw the equipotential line for this rig, the point charge. There is a point charge here. Point charge. Let's see, I draw one. This is the field line. It's a positive point charge. The field line is going outward. The red is the equipotential line. The red is the equipotential line. The equipotential line going to make the same shape as the surface shape, the surface of the body. If the surface of the body which carries the charge is sphere, the equipotential line also going to be a sphere. Going to be a sphere. The equipotential line got a lot. You can build a lot of equipotential line. It can be infinite. So the equipotential line will be circle. You see here the first picture, because parallel plate is horizontal, it's a horizontal line. Equipotential line also is a horizontal line. Okay, can you figure out how the equipotential line looks like for this non-uniform shape? The third one down here is this body. So if it's positively charged, how the field looks like? It's positively charged. The field should be going outward, right? The field should be going outward. But how the equipotential line should look like? Sorry, the equipotential line will take the shape of the body. If you want to draw one, you're going to take the shape of the body. You're going to take the shape of the body outside. Yeah, so this can say the equipotential line. That's the equipotential line. Okay. So same as the what? Same as the shape of the body. Okay. Equipotential line, no arrow. Equipotential line, voltage is actually a vector scalar. Potential difference. Potential is actually a scalar quantity. Scalar quantity. No direction. So we just draw the line without any arrows. Okay. The field is a vector quantity. So that's why you need to have an arrow. Okay. So what is so special about equipotential line? Anything move in an equipotential line, there is no work has been done. So no gain in potential energy, no gain in kinetic energy. Okay. So that's special about equipotential line. This equipotential line not only happens in electric field, it also happens in gravitational field. You know, Earth. Okay, Earth. This is gravity. You'll be doing in A2 later, but just to tell you something about equipotential line, the gravitational field for the Earth is going into the Earth. This is the field line of gravity for the Earth. It's going inward. This is the field line, gravitational field line for the Earth. Okay, so the Earth also will have its equipotential line. It also has equipotential. The equipotential line will take the shape of the Earth like this. This is the equipotential line. Okay, a satellite is placed on an equipotential line. When the satellite is launched, the satellite will orbiting the Earth. Okay, orbiting the Earth. Okay, tell me, do satellite require fuel to move forward? When a satellite is launched, do satellite need fuel to move forward?
No.
Anyone?
No.
Not required fuel. You don't need to supply fuel for it to move forward. Why? Because the satellite move in a equipotential line. Okay, if it's moved in equipotential line, work done is Q changes in V. Still, this are not going to be Q now. It's going to be mass, because for the gravity, mass changes in V will be 0. The work done will be 0. Another word to understand better, for the satellite, what is the only force acting on the satellite?
Gravity.
Gravity. Only gravity is acting to the satellite. But the satellite moving which direction? The satellite moving like this way, perpendicular at that moment. So work done by this gravitational force is what? F times d, 0, right? No work done, but so there is no work done. Therefore, the Earth, the satellite not required, no gain in kinetic energy. It doesn't gain in kinetic, doesn't gain in potential. Therefore, it does not require the fuel. The only thing they have to do is, when they launch it, they launch with the specific velocity enough. So you're going to keep on rotating the Earth for a few years, for a few 10 years maybe, and yeah. So that's the specialty about equipotential line. So anything launched in equipotential line, we don't need to supply it with fuel. It's just going to move around consistently. Okay, but the satellite, the gravity of the Earth is, because it's not same in every point. Okay, therefore you need to have some energy later, because to pull back. If the Earth is uniform, gravity is constant, then the satellite not required any fuel. It can move around if it move in equipotential. Okay, so my highlight about this slide is, anything move in equipotential line, work done is 0. Therefore, no gain in potential, no gain in kinetic. There is no gain for potential and kinetic. So no fuel is required. Okay, any questions from this slide? It's fine, Okay, let's proceed. Okay, as I said, an equipotential surface is a surface on which all points are at the same potential. No work is required to move a charge at a constant speed on an equipotential surface. The electric field at every point on the equipotential surface is perpendicular to the surface. Yeah, the electric field and the equipotential are always perpendicular to each other. So keyword is no work is done to make it move with a constant speed. Okay. Okay, so we are almost done with this topic. This is the fact of the topic. Okay, one question. What is the answer for this question? Anyone?
A.
A, of course. Should be A line. Should the negative should go to A, So A should be the answer, Okay. So the only creature which uses electric field is, of course, eel. If many of you have been to maybe Aquaria, the KLCC, I think the second aquarium, I think, is eel. Maybe about 1.5 meter long of eel kept inside the aquarium. Aquarium will be stated that it should not touch the surface because high voltage. The eel, electric eel uses sensing a weak electrical signal. It uses for navigation and for social communication. The electric eel is dark and murky. It sleeps in a dark and murky water. It has a very poor vision, which worsens when fish ages. Okay, so the eel will produces electric field from the nose to the tail. Okay, can generate electric field, and the most surprising news is the voltage the eel can produce is around 660 volt. I think, if I'm not mistaken, around 660 volt. Okay, so any predator, let's say, want to eat the eel or maybe a crocodile. So there is one video, I think, in YouTube you can watch. The alligator A eel was just at the side of the river. The alligator go and try to eat the eel. When it grabbed the eel, the alligator was electrocuted with a 660 volts. So finally, the alligator died. So yeah, it can give a shock of 660 volt. So the only creature uses electric field is eel. Eel can generate a very high voltage. The cell, it seems, can generate voltage. Okay. Okay. So any questions so far about this topic? So this is about biology. So a little use of like electric field. Okay. So that's all about this topic.
Yeah.
Yeah. Yes.
Marwan, you ask first.
Okay. Does the electric field is affected by, for example, if the surface, yes, is the equal potential line follows the surface, but does it affect if the mass or charge on that surface is not is irregular at the object?
The mass or what again? The mass? You mean go to the electric? Go to the equipotential, is it?
Yes. Does it is the line affected if the object itself has different mass or charge at different areas of the object? Yeah.
Oh, that means the charge density is different.
Yeah.
The charge density is different. If the charge density different, yeah, the shape will be changed because the potential there get closer. Yes.
Yes. Okay.
It will change. But normally it take the shape of the object. Okay. But yeah, it can change a little if the charge is greater. But normally it take the shape of the object. Okay. So your A level, the one they're going to ask is the parallel plate, mainly the parallel plate equipotential line and the point charge equipotential line. Okay, these two is important. Okay, so I have any other questions? Yes.
Like if a charged particle is at rest at the equipotential line, right, and then
Yeah.
it started moving along the equipotential line, doesn't it increase the kinetic energy to make it move forward?
Yeah. In this case, it's like you launch the charge with the constant speed. You launch it
I mean, just at the beginning, lah.
at the beginning. You launch it. You supply energy first. You yourself giving energy for it to launch it. Once you launch it with a constant speed through the equipotential line, its velocity won't increase.
So it's at a constant velocity.
At the constant velocity, yeah.
Okay. Thank you,
Okay.
teacher.
Okay. So anything move with the equipotential line, we can see that the work is not done. The work is not done. Therefore, why the work is not done? Because the force and the displacement is 90 degrees. Okay. So let's say a charge is moving to this equipotential line. Let's say this is a positive charge. So the force is definitely downwards, but it's moving horizontally. Displacement is horizontal. So force and displacement is 90 degrees. The work done will be zero. There is no work done by the field. So no gain in potential or kinetic. Okay. Okay. So let me ask questions now. Okay. So I have lots of questions in my mind. Okay, these are the questions which are tricky one. Let me show on the whiteboard. Okay, let's see. You have a parallel plate like this. This is positive. This is negative. Okay, so you have an electron here. Sorry, you have a proton here. You have an electron here. Okay, proton on the positive edge, electron on the negative edge, both in the same electric field. Okay, we know the charge of proton and electron is same, but the mass of proton is far bigger than the mass of electron. About 1,800 over times, right? Mass of the proton is far bigger. You now tell me, the proton, and when they are exposed to the field, the proton will move to the right and the electron will move to the left. Okay, the question is, when the electron reach to the positive plate and the proton reach to the negative plate, tell me, the both going to gain kinetic energy. Both going to gain kinetic. The gain kinetic energy by the proton, is it same as the gain in kinetic energy gained by the electron? Or if it's not same, which is greater? Okay, 1 minute for you. The proton moving to the right, the electron moving to the left. They are in the same electric field. Okay, when they reach the opposite plate, do both of them gain same amount of kinetic energy or different amount of kinetic energy? If it's different, which gain more kinetic energy? You can WhatsApp me answer. Same, different. Or you can tell me also from the yeah, now.
Is it the same?
So it's going to be same kinetic energy. The same kinetic energy. Why is it same? Because again in EK should be same as the work done. Work done by the field. Work done by the field. So work done by the field is what? Is the charge possessed by the body times the changes in the voltage. So for the potential, the charge is the same for proton. The charge is the same. The potential difference also the same as the electron charge and the potential. Therefore, both will gain the same kinetic energy. Good. The gain in kinetic energy for the both body is the same because it only depends to the potential difference between the plate and the charge possessed by the body. Okay, good. So the proton and electron will have the same kinetic energy. Okay, now the question never stops there. More question. Okay, the proton both reach the positive plate. Tell me the velocity, the final velocity of the proton and the final velocity of the electron when they reach the plate. Is it going to be same or different?
Different.
Which greater?
Electron.
Electron going to be greater. Why?
Smaller mass and higher velocity.
Yeah, the main reason is smaller mass. Smaller mass lead to greater velocity. Of course, the velocity of electron going to be far bigger than the velocity of proton because of smaller mass. Because mass of E is far smaller than the mass of proton, so electron will have a greater velocity. Okay, good. Okay, this is the one question. Any questions from here?
So can I say that smaller mass means higher acceleration, so fast it goes to a higher velocity faster?
I also get a smaller mass, so greater acceleration, therefore it attains greater velocity. Can. Okay, any other question? No other question. I'm going to ask another one. Okay, now going to be a little challenging. Okay, let me see how many of you can figure out. Okay, now the plate was like this. Okay, the plate, let me show the plate. The plate is like this. Okay, the plate was placed like this. Okay. Okay, first the proton is here, electron is down here. Okay, this is a positive plate, this is a negative plate. Same thing, proton go to the right, electron go to the left. So kinetic energy of proton gain, is it same as kinetic energy gained by the electron in this case?
No.
The kinetic energy gained by both body different?
Different.
Why is it different? Because work done is still QV, right?
The electric field strength is different.
Yeah, electric field strength here weaker. Electric field strength on top is weaker. Electric field strength faced by the electron is higher. Okay. Okay. So the force experienced by the proton going to be weaker. The force experienced by the electron going to be stronger. Okay. But the distance traveled for the proton is larger. And the distance traveled by the electron is shorter. Right?
Yes.
So what is work done is force time distance, the basic idea, right? For the proton, the work done on the proton is the force experienced by the proton, which is a weaker force, but the distance is quite big. Work done on proton. Okay, work done on electron is the force is very huge because it's in a stronger field, but the distance it travel is a very short distance. So the work done for both proton and electron is going to be about the same. Or to be better visualized is this equation better tell you they are same, because both of them have the same charge. They still travel the same potential difference, right? The proton, maybe this is positive 50 volt, it moved to 0 volt. And the electron also from 0 volt to positive 50 volt. The potential difference still 50 for both of them. So changes of V same, 50. The charge is same. So work done on by the field on the charge is the same. So the both will gain the same kinetic energy. So both will have same kinetic energy. So what's the reason? Better use this formula. They have same potential difference. They possess the same charge. Therefore, the gain in kinetic energy is the same. Okay, any question? You understand? Okay, so remember, so two charges moving in the same field, if they, as long as they possess the same charge, the amount of work done on them is the same, as long as they travel the same potential difference across the plane. Okay, now again the same thing. You have like this, a proton is here again, alpha particle is here, proton and alpha particle both move to the negative plane. Okay, which the can you find the kinetic energy gained by the proton over the kinetic energy gained by the alpha particle, the ratio? One minute for you. What is the ratio of kinetic energy gain by the proton over the kinetic energy gained by the alpha particle? Okay, alpha particle, just for your recall back, alpha is actually what? The helium nucleus with 4-2. It's a helium nucleus. Okay, please get me the answer. The gain in EK of the proton and gain in EK of alpha particle, and the proton and alpha particle reach the negative plane. What is the ratio? Can all of you WhatsApp me the answer? Come on, hopefully all of you give the correct answer. The gain in kinetic energy is, oh, I received the answer. One of you said it's half. Oh, well, two of you said it's half. It's half, Is it half? Yes, could be half, right? Because work done is by the gain in kinetic energy of the proton is Q times changes in V, but the charge of proton is actually is 1e, 1e. E is the elementary charge. I told you it's like 1.6 times 10 power negative 19. We don't need to substitute the value. We just leave it as 1e. Okay, V is the voltage between the plate. Okay, then work done by the alpha is Q changes in V, but the alpha charge is this. Alpha charge should be positive 2e, same voltage. Yes, the charge is double, so work done on the alpha is 2 times greater. So answer should be half E. Should be half. Very good. Okay, good. So answer should be half V. Okay, so this type of question they will ask. Any question from this? Okay, so all of you understand. Okay, good. Okay, so now we're done with this topic. So we're going to go to the questions now. So it's time to do the questions now. Later 1 hour also we'll be doing more questions about electric field. So I select some questions. Let's we do together. Okay, we're done with this topic already. Okay, so the first question I'm going to select to you is let me scroll down. Okay, this one. Page 6, question 36. Send me answer through WhatsApp. Come on. Okay, the only formula you learn in this topic is electric field is F over Q, V over D, and work done across the plate is Q changes in V. The work done is same as gain in EP. Okay, sometimes it could be same as like gain in EK also. Gain. Okay, 36 was the answer. So I receive answer. So one of you said B. B. Okay, good. Good. Many of you, all of you said B, and 3 of you said B. Okay, so should be B. It's more mathematical, right? Okay. So the two plate. Sorry. What is that? What is the electric potential when the plate of both V and D are double? V and D double. So E is still 2V, 2D. So it's going to be same as V over D. So the field is still the same. So E. Okay. Okay, this one. Page 9, question 29. Okay. What's the answer? Okay, send me the answer. So, Okay, I receive answer. One of you said A. The others said A. Oh, good. Your class is good. So 2 of you said A. Okay, it should be A. Okay. Although, what is this sign? This sign is actually Earth. That the terminal is Earth. Earth means should be 0 volt. 0 volt. So 0 volt, of course, is not positive and negative. But the sign given here is the sign relative to the other plate. Relative to the other plate, is it positive or negative? That's the meaning of the sign. Because this is 0 volt, okay, 0 volt, and the field line is upwards. So the down plate should be positive relative to the upper plate. So you need to put positive sign, although it's 0 volt. Because this positive sign is actually a sign relative to the other plate. Relative to other plate, is it positive or negative? That's the meaning of this sign. Although 0 volt, you must put positive. So the answer should be it's A lah. It should be A. Okay, good. Okay, let's move on. Selecting some. Okay. This is okay. It's not a typical one. Okay, this one. Question 30. What page is this? This is page, page 16. Page 16, question 30. And me the answer. So send me answer through WhatsApp. Hope the same answer. Okay, so I receive answer again. So A, one of you say A. Which expression give the electric force F on the electron? Good. So both of you say A, two of you say A. Okay, so is it A? So an electron of charge E introduced between the two metal plate a distance of d apart, a potential V is applied. Which expression gives the electric force F on the electron? Electric force F. Oh yeah, so F equals to QE lah. So this is straightforward, and QV over D. Okay, so this is straightforward. Okay, baiklah. So I'll come up with more questions. The one trickier one, let me ask you verbally later. Okay, so I see you later at 12 o'clock. Any questions so far about electric field? We'll be continuing with doing more questions about electric field. 12 to 1. Any questions? So no questions. Okay, good. So I see you later, 12 to 1. Thanks.